Somebody else going to be at PCB East presenting to Mr. Stanfill?
Yeah.
Yes. Yeah.
Tell us about what you're going to talk about. Give us a sneak peek.
Well, I mean, I feel so sheepish after Sean is spreading his expertise in a similar area locally recently. I'll be talking about placement.
Hey, Daniel, can I stop you for a second?
Mm-hmm.
We just calmed down a little bit. I know. just bring it down a notch, bud. All right.
Lay
Continue.
off the espresso. Go with a little decaf.
The problem is, there didn't used to be coworkers around when we recorded, and now that there are, like, I have this problem. How do I actually
performance anxiety? We are back, and we're with our good pal, and it feels almost surreal to say that because I remember the first time we had the Chrys Shea on, we were all scared little boys to talk to her, and over the last year, we've been able to spend a ton of time with Chrys and even had opportunities to work together with her on projects, which is just an honor. So welcome, Chrys. Thank you for gracing us with your presence tonight, wherever you are.
Thank you. I'm in a hotel again. I'm always coming to you from a hotel in Burlington, Massachusetts.
So speaking of coming at us from a hotel room, last year when we were talking to you, you mentioned that, maybe this year you wouldn't be out and about as much. You were going to kind of take a little bit of a step back, but in talking to you recently, it seems like you failed at that and you're as busy as ever.
Epic failure. Absolute epic. Every time I try to back off, something more new and exciting comes along. And it's a sickness. You guys know it. Elias, you have it. Sean, you have it. Daniel, you have it. Paul, you're infected too. And
Yeah,
everybody who gets on your podcast and everybody who watches the podcast, Circuit Assembly is so much fun because it's always a new challenge. I can't, as much as I try to pull myself away, I got the sickness.
It's like the Hotel California, right? You can check out anytime, but you can never leave.
Exactly. I think I checked out for like a month or two and I was like, all right, this is boring. What's life without Circuit Assembly?
Plus, you could use the excuse it's winter time, the snow, you can't really go outside much right now, so what else is there better to do, right?
Exactly. Well, spin artwork for a circuit board. Duh.
What have you been doing? Where are you now and why are you there and what's coming up?
I am up here in Massachusetts because I was at Palmy today working with Michael Butler. We're doing some print tests. Yes. For non-New Englanders, that's Palmy. And the engineer is Michael Butler. But we all know him as Butler.
Yeah, that's right.
Yeah. So we were doing some print tests, and things were looking really good. And the last time I did this particular print test was, maybe 2010, 2011. So the SPI machines can give us so much more information now. The microscopes and the lenses and the imaging chips can give us so much more information that we were having some fun with it. And I was like, we can do better than this image-wise. So you go to Amazon and you can get this really cool microscope on a stick, 3 different lenses, LCD screen, and it's actually a little soldering workstation. It comes with a little blue mat and places for your iron, your picks, and all that, and little gooseneck alligator clips so you can clip the board so you don't have to sit it flat. So I'm all excited about this because now, we not only can we take complete top-down pictures, but then we can tilt the board and really kind of look at the shapes of those little bricks. So that's my excitement for today. What about you guys?
Well, I'm actually in a hotel room as well. I'm out here in Austin. I came out for the SMTA Austin chapter event and worked up enough nerves to give a talk today. So that was exciting. And believe it or not, the weather's better here than it was back home in San Diego when I left. We had a little bit of rain. It was one of our 8 rainy days for the year. So I'm not missing any weather back home.
How many times have you presented now, Elias?
I think that was my 3rd in person, and I've done a webinar. I also am fortunate enough to take part in a webinar with our very own Chrys Shea here, coming up in next week.
Next
Is it
Thursday,
next week already?
a week from now. A
Yeah,
week from
so
now, 1 p.m. Eastern. Oh, it's hosted by Raka, by our friend Justin Warden, and it's Elias and me and Debbie Carboni talking about stencils and printing. And a good print starts with a clean stencil. And
should be
can I
so
say
much fun.
this? Nobody likes a dirty bottom.
You
That's
just
safe to
gave us
say.
our
Don't make that the teaser. I'll give you
I was
something
just going to
better.
say, you just gave us our magic clip.
Now you can
Yeah,
see
there it is.
why we love Chrys so much and why we get along with her so well. She's,
Yeah. So anyway, that paper is really good. If you think about, I'm going to get on a little nerdy tangent here, but for years and years and years, we used this coarse woven polymer paper, and that coarse weave would kind of just get in there and scratch the solder off the bottom of the stencil, and the coarser the better, and and grab all those type 3 solder spheres. Well, anyways, then we came out with nano coatings, and they don't like the abrasion that those really tough papers put on them. So you go back to a softer paper and you're getting the flux out, but you're still smearing stuff. So a couple companies have this pocketed paper, and it came out at least 10 years ago, maybe longer. But anyway, this pocketed paper actually grabs those little spheres systematically instead of randomly. And as the powder sizes get smaller and smaller, the point of using pocketed paper becomes more and more apparent. Because
And the
it's hard to remove
deposits
those
go in.
spheres.
The deposits go into the pockets, and then the flat surfaces are still working to collect and move it into the pocket rather than just smear it all around and leave fibers on the inside of the aperture walls and such, right?
Exactly. I kind of termed it, I don't know if you remember the TV commercial for some kind of paper towels, Bounty paper towels back in the 80s and 90s. Rosie, the waitress of the diner, it's the quicker picker-upper.
right.
Yep.
Right.
So you do kind of remember that.
Yeah, those patterns aren't all that different, right? They had those kind of mounds and pockets, and yeah.
Sure.
Yes. And I mean, if you think about it, you're eating a pizza and it's maybe a little greasy. If you use a lousy paper towel, you're just smearing everything everywhere. But you grab your quicker picker-upper and you get your stuff cleaner faster. So that's kind of how I analogize the wiper paper. So anyway, we're going to be doing, it's not a webinar death by PowerPoint slides. It's the 4 of us talking.
It's
And
it's not that dissimilar to what we do here on the Decode podcast, right? Maybe there's a little
Exactly.
inspiration for it from our format. It's real people
Imitation
having
is-
real conversation.
Yep. I think imitation is the sincerest form of flattery. And
with
you
you
guys
and
really
Debbie
started
and-
something.
With you and Debbie and Justin, you'll be able to at least pick up and provide both information and entertainment when Elias is kind of dragging the whole proceedings down. So
Sure. Yeah.
that,
Yeah,
that
yeah.
would be helpful.
Yeah.
He couldn't carry it himself. He is actually, he's an ornament. It's all about Debbie and me.
He's been ornate.
He's not going to get awarded edgewise if you put Debbie and me together talking about printing and underwiping.
Yeah.
He's going to need a little flag to check something here and there.
And neither one of you needs a microphone, right? Anybody within 100-mile radius will just be able to open their window and hear you.
Yep. If there's less than 500 in the room, no mic needed. Yeah.
Debbie's-
And then we're both presenting at PCB East at the end of April, too.
Is somebody else going to be at PCB East presenting too, Mr. Stanfill?
Yeah.
Yes. Yeah.
Tell us about what you're going to talk about. Give us a sneak peek.
Well, I mean, I feel, I feel so sheepish after Sean is spreading his expertise in a similar area locally recently. I'll be talking about placement
Hey, Daniel, can I stop
placement
you for a second?
concepts. Hmm.
We just calm down a little bit. I know, just bring it down a notch, bud. All right,
Lay
continue.
off the espresso. You go with a little decaf.
The problem is, there didn't used to be coworkers around when we recorded, and now that there are, like, I have this problem. Like, how do I actually
Performance
show?
anxiety.
How do I show emotion that they've never seen when I'm at work?
Plus, it's the indoor voice.
Yeah, exactly. No, I think I'm doing at least basic placement concepts and probably more.
Yeah. He's gonna do the basics in the morning, and the afternoon he's gonna talk about all the cool stuff he's found flying around the country, looking at all the latest and greatest placement stuff. So
Man,
I'm
she's
looking
seen
forward to
some cool
that
stuff too.
Oh, I know. I'm so jealous.
That's when I actually will get excited. I can't help it once I actually start talking the specifics of equipment. I love that stuff.
The sickness.
Yeah, exactly.
The sickness. No, I'm looking forward to that. This is the first year that PCB, East, West Carolinas, whatever, has done an assembly track. Because it's traditionally been designers and fabricators, and fabrication and assembly are converging.
Show me one person who can walk past an assembly line and not be interested. Like, they don't exist in this industry, right? I mean, this stuff's
it's too cool.
It captivates you. Like,
yeah, it's addictive. It's truly addictive.
Sean, Daniel was alluding to you and your instructor prowess. Do you want to talk to us a little bit about what you've been doing recently in terms of educating the masses on placement best practices and so on and so forth?
I mean, the beauty of it was, to be honest with you, was like,
how did you get ChatGPT to present?
Well, that's the beauty I was about to talk about. It was like it was 90 to 100 slides that were created for me, right? And I just had to basically read the bullet points and expand on my experience on those, right? So it was if I had to create that, I don't think it could have been done, right? There's no, it definitely would have been used some AI to do that. But yeah, I was speaking on component placement for the SMTA and their SMTA live learning class. It was interesting, the collection of people, right? There was some people who had zero experience in assembly, and they were hired as they're part of component sales, and they just have no clue about any of that part, so they wanted to be on there. And there was people that had 7 years programming and running lines, and there was a guy there with like 30 years experience that basically ran his entire CM shop. And so it was like a plethora of us, and it was really fun to fall to like kind of use the experience, and I kept picking on the new guy, just trying to make sure he was learning, and kind of quizzing him as we go along. And they had this fantastic picture of a tombstone. I have never seen one so pronounced up in the air in my life. But it was so wild that it was like, I'm like, they had a hands-on of this, It was just amazing.
The Statue of Liberty.
Yeah, it was like, man, how did they recreate that? They had to hands-on it, because it was seriously just.
If they had that in a video, it'll look cool, though.
Yeah.
You bring up a good point, though, and I think that's something that Chrys really excels at, but it's challenging, right? If you have sort of a mixed room and you're presenting or instructing or whatever the case is, and you've got this mixture of really seasoned vets and maybe some people that are hearing this information for the first time, wrapping that information in a way that's digestible up and down that food chain. And I instantly think of Chris's example of the grilled cheese sandwich and talking about reflowing, right? So, that's to say, anybody can understand it, whether it's your first time hearing about it or maybe it connects the dots after 100 times hearing. But that's tough. That's always tough, right? How do you sound smart enough, but then make it simple enough to the entry level or maybe the students that are in the room, which is increasingly the case now, right? We're seeing a lot more engagement from, young professionals or pre-professionals coming out of college or, even high school.
What I loved was we all had this common experience that was shared in the background, and you feel kind of crazy. So we all had tombstoning before, and every single CM in there, the majority of it, the problems arise because the PCB designer made one pad bigger than the other.
Thermal imbalance.
And they don't get to communicate with us, right? They don't talk to us often. And that's what I love the most about all this is to try to get people who are siloed in their industry to realize, hey, your actions affects people downstream.
Yep. That's why we have Tombstone Alley on the test boards, where we have one pad that's etched to fine, and the other pad is out of a big ground flood. Yes. And we just respun the SMTA board, and we put the Tombstone Alleys on the new spin of that too. That's
there
not
are some really cleverly named sections in that board.
Yeah, it's fun. Like I've been doing test boards for so long, and we always end up naming the thing something, So I was like, well, instead of waiting till it's a couple years old and calling it this or that, we'll just give it some fun names right up front. Tombstone Alley, excuse the placement. Some of them on the Ultra HDI board are named after the people who suggested them, like Shake Up the BGAs and Justin Casey on the 0603.
That's cute.
Yeah.
I would like a dedicated section called Kincaid's Corner.
We can do that.
And all it is just components you send through the reflow. You don't inspect them. Don't look at anything like that. You just
send it.
I know. We'll pull the resistors and the caps from the tape. We'll shake them up. We'll throw them on. And we'll let the chips fall where they may.
You never know what's going to happen.
Oh, that was a horrible joke and you didn't get it.
I did. I could just see Sean doing like Salt Bay style placement, right?
Yeah.
One's got to stick if you throw enough, right?
Yeah, exactly.
I got your let the chips lie. It'll take me a minute, but I'll get there, Chris.
Okay, all right. Yeah, I like.
In 4 minutes, you're just going to see him start laughing hysterically, and then you'll know.
No, like 10:56, he'll start laughing hysterically.
I'll text Chris tomorrow. I get it. No, but I did have a problem. And actually, Elias, and I always dog on him because he's like IPC certified and stuff like that. And I called him one day about this pin and paste problem I was having. It was depositing too much paste, right? And then the pins were floating in the air a little bit. And I called him, and he's like, well, what's your speed at, right? And I was like, stay in your lane, stencil boy. You know what you're talking about. Go back to cutting metal. And then it so we turned it up, and it actually helped reduce the volume of paste that was printed on it, right? Like it was actually really helpful for that he did that. Please edit all that out. But no, seriously, it was really messages. Good. But what I didn't realize, and thankfully, we got a new 125-inch oven, and so we're a lot more thorough on our maintenance checks on it, right? And just making sure it's greased and it's oiling correctly and stuff like that. So we opened it up after we only ran one that day, and we opened it up, and I didn't realize that paste could fall through, right?
Hot slump.
And so
slump.
Is that part of the reflow profile that wasn't dialed in? Was it too much paste? What was caused? What causes that to leak out almost,
It's called hot slump. Like the paste stays a nice brick at room temperature. And then when it gets to the oven, it starts slumping down, like not right in your ramp, but in your soak zones or like zones 2 and 3. That's when your hot slump kicks in. And some pastes have better hot slump than others.
Interesting.
So like, I'm not going to like blah, 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 blah on the podcast, but offline I can tell you like, who's got worse hot slump and who's got better hot slump, because we test for it when we do the SMTA board. We have a little slump pattern right there. And another interesting fun thing about slump, especially hot slump, it changes with stencil life. So your hot slump characteristics right out of the jar are good. Run that paste for 4 hours and see what the hot slump characteristics look like then.
Wow. The amount of printing you must have done to find that out, right?
Yeah, it's in my blood.
Well, and I think that's a good segue into talking a bit more about like using a test board as opposed to just trying to learn on the fly with actual product. Talk to us a little bit about kind of the methodology or ideology behind, like, let's figure these things out before we get into production and before we start bumping up against them in the real world, right? So that's kind of what I see as the value in using a test board, but I want to hear your take on it.
Well, as a production engineer and even as an NPI engineer, sometimes you don't know a new component package is coming your way until you see it on the BOM on the first build. And you're like, what is this? The first QFN, or it was called an MLF back then, in 1999.
Yeah, where are the leads?
It was on the BOM. There was a footprint on the board, but when we're looking at board artwork, it looked like it was probably just a QFP, you know? Yeah. And like, oh, like, what do we do with this? And I have a lot of people saying, you know, suddenly a 0.4 millimeter BGA slipped in on a design, especially the contractors. You got no control over it. And at first, it eats your lunch. So if you know it's coming, you can get ahead of it, which is almost unheard of in assembly because everybody's like, get the boards out the door today, worry about tomorrow when it comes. So, but having done so many test boards over the years, and then having worked with so many other companies that do their own test boards, it seems like, hey, why don't we put everything on one test board? And it's inexpensive. It's 2 layers. It's got, well, the version from 2018, it's got everything down to 0.3 millimeter BGAs. The new version that we're going to be rolling out at SMTA has hundreds of O201s. Yep. Hundreds of bottom terminated O201 diodes. You know, those things we love to hate. Oh, yeah. And a couple of different O201 footprints because I was pulling data sheets and pulling down the pad stacks from the part suppliers. And they're all recommending for O201s 12 by 12 pads with 12 mil air gaps. And I'm like, I think that's kind of begging for some tombstones there with that big of an air gap because we usually run like 8 or 9. And our standard pads were always kind of like 12 by 15. So I put a set on that were the regular 12 by 15, 9 mil air gap, and a couple hundred 12 by 12s with 12 mil air gap. So you know what? If this is what's going to come through on the boards, whether I think it's a good footprint or not, this is what the designers are downloading from the product manufacturers, and this is going to end up on our boards. So again, like you can buy these boards for like $30, $35, use them over and over and over again if you're not reflowing them, and you're not losing yield and you're not burning customer boards. Because as CEM, how often do you guys get spare boards to play with?
One. I get one.
Which drives me crazy as a stencil guy because somebody will send me a board, you know, to get panel data off of it or whatever. And it's like, send it back. I'm like, send me a solder sample, like something I can throw in the scrap bin afterwards.
Yes.
Sorry, I got ranty.
Oh, but speaking of solder samples, do you guys recall last April when we did a podcast with a solder sample for this board saying I came up with this whiz-bang new hot air leveling process? What are we going to do to top that this year?
That was so good. We hung on for way longer than I thought we were going to.
I thought we went like 6 minutes.
Yeah, so I can think of something that involves the end of the train, but I don't know if we'll be able to air it, right?
Yeah, no, again, it was better when I was younger.
Well, maybe we could take the torch up, right? Like maybe that can be.
Yeah, there you go. There you go. No, we have to think of a better April Fool's prank this year. That's going to be a little tough to top because some people actually fell for it.
Yeah, for
Yeah,
sure.
they did. Yeah.
For
What
sure.
did we call it? I wish I could remember.
It was
We'll
a
go
long
back and-
acronym, right? Then we have a long
Yeah.
acronym. Yeah.
So
Yeah.
it was an acronym that used the A,
April
F, and
Fools.
D, right? Yes.
Yes. A, F, and D. It was. We'll go back and look at that again, but that was so fun. We held on for 6
Atomic
minutes.
something.
Daniel almost blew it for us.
Yeah.
Couple times.
Which is just the most stoic of all of us. That like Daniel excited, Daniel mad, Daniel happy. Like it's the same face, and he almost blew it for us.
Yeah.
just
Up
did
here in
all-
New England, we used to always have T-shirts and sweatshirts that had 9 pictures of Bill Belichick with all his different emotions, and it was always the same face, like Daniel. Belichick happy, Belichick sad, Belichick angry, same face. Belichick won, Belichick lost, same face.
Recently at Panpack, there was this high school student.
Oh,
who
wait!
had
You had to drop in. I was recently in Hawaii. Okay, go ahead. Keep going.
I didn't
thought
mention
you'd be Tanner.
where it was, but yeah, sure. And I was bringing up AI and some of its more evil uses, and talking about how Paul actually used it once to produce a clip of me that I didn't actually say the words, and I was hearing it, but it sounded exactly like me saying it. And I was saying how crazy that was, and the high schooler, like inadvertently or not, was totally roasted me. It's like I noticed, because his presentation was on AI. He's like, I noticed that people who are kind of like don't use as much vocal range when they speak are easier for AI to imitate. And I was like, no, I get it. I was like, emotion was like sucked out of me 10 years ago when I had kids and owned the business. So from now on, it's just one level from here on out. This is what you get.
So
Chris-
really, the more inflection in your voice, the harder it is to mimic it in AI.
Yeah.
This is really interesting because I'm doing training where I'm doing a voiceover, but then Doug Dixon is going to take it and change my voice to an AI voice that sounds like me, but like my S's hiss and I go a lot and stuff like that. So to clean it all up, he's going to take it and convert it to AI. Now, I never speak in the same tone. Like even a single word or syllable has different inflection on me. So I wonder how AI is going to copy that. That'll be interesting.
Just breaks.
Good chance.
Yeah. So that'll be interesting.
So we got off topic, but
I do want
to.
to loop back to that test board of yours, Chris, because
Okay.
Interesting. That's what I was just doing.
it's gonna sound
So about the test board.
well, no, it might sound weird to you. I don't know that it was weird to me, but
Wait, what?
well, because she's been doing this for so long, and correct me if I'm wrong, but your board is designed to fail. And,
Yep.
and the thought of that at first was just mind blown. You know what I'm saying? Because it's like,
Yeah.
why would I want to? But without seeing where my failure limits are, right? Like I won't be able to improve anything. And I recently tried to do like a selective solder flux DOE, and I made one, and then I stopped right when I was about to release the Gerbers, because this isn't designed to fail. And I kind of used that. I kind of used you as my motivation of like, I got to make this harder. This thing's got to fail. We got to figure out how to get this thing to fail.
Exactly. Like think about it. Like if you were a teacher and you gave your class a test and everybody got 100%, that test wasn't hard
a
enough.
good test. Yeah.
And I always maintain that you never know your limits until you push them. And
Yeah.
it's
and
no
then
surprise to you guys that I like to push limits.
And when you do find those limits, like for instance, I mean that new board has what, 008, 004s? Is that the smallest component on it?
It does, but the new Ultra HDI board has the
Even has-
006, 003s.
Oh, boy.
And I conspired a little bit with Jeff Shake from ASMPT because he's doing a test board for the 006, 003s. So we have some common footprints on both
Have you seen
boards,
one-
but that we can compare.
Have you seen one in real life?
No.
Nobody
No.
has. They're too small to see.
Yeah, I don't
Yeah.
think you.
But it's not going to stop me from putting footprints on the board. It'll be here sooner or later. When I did the 0804s on this board, I don't think we had in
How do they
production
even get
yet.
inspected? How can you even inspect a 006, 003?
Yeah.
I don't know if there's an AOI out there.
Higher resolution.
What I was getting at, though. So obviously, you're not going to have a successful print process with 100 micron thick stencil and 0804s, let alone 00603s. But once you find, kind of where you're at in terms of area ratio that you can print at with a 100 micron stencil, and you want to dial your process in for a 006 003 or a 08 004, you can then pull the levers on stencil design, use a thinner foil, and then use the board for success still at that component complexity, right?
Yes. And one of the things, like a lot of times you'll see other test boards where the different components are kind of spread all over. And they're all blocked. Like, okay, there's your 04s, there's your 05s, here's your 03s, so that you can step the stencil down.
Right.
Reasonably.
How thin can the foil get before the aperture size is too large to still have any integrity, like between the two pads?
So, I mean, currently down to like 25 micron foil is the thinnest.
Why do you
cutting.
Keep talking mils, man?
Sorry.
Nobody buys 100 mil micron. We buy 4 mil stencils.
1 mil.
1 mil.
1 mil.
Thank you.
There you go, Sean. That's
Thank
1,000th of an inch. Okay, 0.001 inch. To get to your question, though, Daniel,
it was on my Google. I know what it is. Okay.
It comes down to the space in between the apertures that really is critical, right? Because now you're creating
right.
these thin
so if
webs.
you have 25 of thickness, how much of a spacing between your apertures do you need to still be safe?
50 microns ish with fusion laser cutting.
2 times the stencil thickness.
Yep.
It used to be 1.5 until stencil foils got thinner, and then we made it 2.
Thank you, Chris.
Yep. and that's using kind of like the laser cutting technique of record, right? Because it's melt and blow. We're using either pressurized compressed air or oxygen at somewhere around 12 bars. So you can push that further
with that MLab than
because there's no gas. There's no gas. So you can get down to like 15 microns. It's insane. But certainly stencil foils trending thinner and thinner and thinner.
And when we do that, we need stronger steel because the plain old stainless, the web's not going to hold up. It's going to get bent, gouged, busted. So
or nickel cobalt is getting relatively popular in those very thin values because it's multiple times harder than stainless steel. So that adds a lot of, I guess, survivability to the stencils with really tight spacing and thin foil.
Yeah, one of the things I worry about with really thin webs is when people want high tension foils, because on stainless steel, a thin web under high tension, you may be pushing it past its yield point really, really, really easily, much more quickly than you thought, because you have such a tiny little cross section on that web.
That's a sore subject for Elias about tension recommendations on stencils.
Oh, really?
He gets really fired up about it. It's like this #1 fired up thing.
It's just
He's
so
got
arbitrary.
the Daniel face.
Everybody wants to talk about stencil tension, but nobody can give you what's good or bad or otherwise, right? It's just a very
That sounds like somebody who doesn't do very good tension.
Well,
I mean, the tension you want, I'll give you 100.
I mean, I think there's a double-edged sword to the high tension argument. The argument that it deflects less or springs back less upon release or separation is a valid one. Because when you're separating and you got the war of good versus evil and the paste sticking to the aperture and sticking to the board, that stencil does bend a little bit before it separates. So in that sense, you would get less deflection of the stencil. But go look at your stencils that you've worn in production for a while, and you can see the board image on it. The stencil has to be thin enough to conform to the topography of the board. So my concern is if it's really, really tight, will it conform to the topography of the board? Or will it actually work against you in gasketing? So I did studies on the high tension stencils on this board maybe 10 years ago, pre-COVID, somewhere in the pre-COVID era. And we did nano coating and high tension, no tension. So clearly there's a huge difference between nano coated and not nano coated. But the difference between high tension and standard tension, high tension being in the 50s and standard being in the 30s, the data didn't show us anything.
Wow.
Now I've heard from people who switched to tension that it's way, way better, but show me the data.
Might be a placebo effect.
You know, is it a placebo effect because somebody said, here, run my high tension stencil? Did it run on a different cutter? Did it have different walls? Did it have a different nano coating? So, yeah, you know, when I ran the data, I didn't see it.
Chris, while I got you here, I love picking your brain while I can. I had this nasty job where they have these aluminum cans now that not only have like the extrusion parts at the end, right? But they have this huge, almost BTC part of it on the edges to kind of really secure it on there. But the pad size the PCB designers keep using on this thing is this
gigantic, right?
It's unbelievable.
And the thing skates all over the place, right?
Yeah, and then like my paste volume is so low, it almost looks like there's no solder paste print. Like what, other than overprinting, I mean, there's only so much I can overprint. Do you have a recommendation, or is that just a step? That's got to be a stepped stencil, right? I don't know what else to do in that.
Because you want more paste, or you want less paste?
Way more.
Do you actually have a defect?
What's that, Daniel?
Do you actually have a defect?
Yeah, it's not enough paste. There's not enough paste. There's no fillet on the side walls of the actual lead itself. It didn't like wick up at all.
Is that because you didn't have enough paste, or is that because those sidewalls aren't very solderable?
I would assume not enough paste, because when we took like a syringe of paste and we added it to it, it wicked up completely beautifully. It was completely fine.
I think you need to buy a new stencil from Elias.
I bought that stencil from him, but I
need to buy another.
he cut it to what it's a giant pad on there. It almost looks like a D-pack almost,
Was the syringed paste the same exact formulation as the jar that you were using? I mean,
where do you think I got it from, dude?
The same type. I mean,
JBC sells this.
I'm just saying, usually to dispense it, it's usually thinner than out of a jar.
I take a jar and I take this nice toothpick and I shove it into this tube, and then I have this JBC tubes, and you just squirt it onto the board, right? And it's like spring based, and it just keeps pumping until you have enough.
That little handheld deal.
Yeah.
Those are pretty cool.
They are cool.
Yep. So you need a bigger aperture to put more paste down. Do you have room for overprinting it?
In one area I do, but on the other end of the pad I don't.
Then we need to go higher. We need to go into the Z. If we don't have X and Y, we can mess with Z, right? A step.
Yeah.
Yep.
Yeah. And it was just
that's just big stencil. Making recommendations.
And get up the Dremel tool. Open up the aperture a little bit, see if it works before you spend any more money.
Grab the Kapton tape.
You both have done it. You've both done it. Yeah. Put a little Kapton on so it's like entry and exit material so you don't burn up too much.
There's 805s right around it too. So it was, and they're pretty close. I don't know the exact measurement, but that was my fear too. Is if
you made the stencil, Elias? Does he have room to step it?
I mean, I love how you guys always think I'm just going to recall.
Right
and right now. You remember that one we did last week? Like, I know that was the last job that you did, but there's been 1,000 in between them for my mind. I don't know.
Okay, Rain Man, I'm going to give you a job number, and I want to hear aperture count, foil thickness, and no, sorry.
Tension.
Yeah.
No, but I
I'm
think
going to
that's-
show you a praise print, and I want you to count the number of solder spheres in that print.
Yeah. Yeah.
That is a
Carnival
good
trick.
example. A good example of like, I mean, Sean, you and I have done it in the past. Daniel, probably a few more times. But looking at the Gerber data, right? I mean, we're looking at 2D. We're just, where does paste need to go, and we're making decisions based off that without seeing the component data sheet, without having access to the BOM, without knowing what's actually going to be mounted on there. How can we make an intelligent decision? Oh, well, this has whatever the specific circumstances are, we need to do this or that or the other. So that's where that kind of collaboration and communication really comes into play. Like now, if you see that next time, hey, last time we did this, this is the actual condition of the component. The leads are way smaller than the land. I need more paste. Okay, cool. Let's get to the bottom of that.
I was just showing somebody how to program jobs today, and on our CAD software, when we're taking the Gerber data and presenting it to create the machine program, you grab a set of pads and it'll grab all the like ones, and you can assign your reference designators and such. And it threw me for a second because the diodes got swept up in the same as some of the 0402 capacitors and resistors, and I'm like, well, that's great. Usually the diodes are going to have at least a slightly different footprint so that it'll have a different decode, right? And won't get grabbed with all the other ones. But if you're, as a stencil maker, getting that, and it's got the exact same dimensions as all the other 402s, and how are you
the silk screen is our only, in an ideal world, we would be getting intelligent CAD data all the time, ODB++, and we would actually have a full picture into it, but that's not the world we live in, right? I mean, we're happy if we can get anything more than just a basic paste file. But that's to answer your question. That's one of the reasons why I always tell people send the silk screen layer, please, because we need it if we're going to perform directional modifications like home base, right? Imagine you've got this whole forest of 0402s, and it's really difficult for us to tell which direction they're running. Does the pad on the left belong to the one on the right or the one below it? So,
and if you've got home plates and you want them facing each other, you need to know which direction to go in. Yeah.
So the silk screen is really important there. And again, in the case of your diodes, it's going to have a different reference designator. So at least that would tip us off to, okay, this isn't just a regular, resistor or capacitor. It's actually a diode. But that's behind the scenes look at what we
Chrys
have to deal with.
I've got another, we don't need to let any of us shine. This is your, do you ever recommend, lowering the board before raising the squeegee, separate the board from the stencil after the print before the squeegees separate from the stencil?
Squeegees, let me think about it now. I don't think it's going to make a difference whether the squeegee is contacting the stencil or not when you're separating, because the squeegee is outside the print area by then. And for me, the thing about separation is most of the modern paste, they're so elastic in nature, you got to do it fast.
Mm-hmm.
If you're running an old RMA, you got to separate it slow because you're kind of coaxing it out of the aperture. But if you're running anything that's like a lead-free made in the last 10 years, it's going to want to separate fast. And I do this demonstration with silly putty where, I've actually done this in classes where I bring silly putty eggs and throw them out at people and have them pull it real slow, and you see the big string, wind it back up and snap it fast, and you see the snap. Once you do that, you will always use fast release because you'll know.
That's good.
I'm not kidding. I had silly putty eggs with my logo on one year. And I'm like, Oprah, you get silly putty, you get silly putty, you get silly putty.
I've heard somebody reference like step separation before, like certain screen printers. Yeah. What's the deal there?
Okay. Well, before we got these modern pastes, when we were still running like rosin-based tin leads, we always had stepper motors on the Z-axis in our printers. So, and if you ran it real slow, you would actually feel the vibrations of the micro steps. Okay. Then we got smart and we're like, hey, we're going to put servos in and that's going to be smooth as silk. Well, when we put the servos in, it went smooth as silk. The paste didn't come out of the apertures. It likes the because those vibrations is what we realized later after playing with ultrasonic transducers and everything else, was those vibrations caused the paste to shear thin right at the walls of the aperture. So it helped like loosen it up right around the walls and bring it out. But now we had these super Hootis at the time, $300,000 printers with servo motors on the Z-axis. So, you know, why do a hardware fix when you can do a software fix? So we came up with the separation profiles. So you can actually go, or you could go, and you could do all kinds of stuff with them. That's
So it was actually
from,
like an unintended benefit of older technology.
Yep. And my friend Ed Noss would always analogize it as to, you go to the beach and you're making a sand castle and you pack all the sand in the bucket and you turn it upside down and you lift it up and the sand is still in the bucket. So you go tap, 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 tap and lift it up and the sand comes out of the bucket.
Sure.
Same thing. Again, one of those simple analogies. You're like, I can see that. I can see that. Yeah. Yeah. So that's where that came from. It
Daniel might not
probably
get that.
25 years.
Not many beaches in Nebraska.
Oh, but actually, recently I was on a beach. I don't know if I've told you guys. I went to Panpack. That was located in Hawaii. Right.
Yeah, and you know, I thought you'd be Tanner.
Chris, I was mad. I was really, I expected from him, and I even texted him to try to get him to do it, but he sent me a picture of him on the beach, and I was like, well, where's the heart in the sand with our initials, right? Like, you should have at least put
He
that.
didn't send you that? I got that.
You got, okay. All right.
I
Yes,
got the
everyone
picture
got
of him
one.
with a coconut bra and grass skirt. Did you guys get that?
That was meant to stay private.
Man,
Oh, sorry.
you got to watch it. Elias is really, he's
You
really
should
good
have
with
put
it.
private on it when you texted it.
Elias is really good with the Gemini AI.
Yep, it's happening. I might have it done in time for producer Paul just to inject it right here.
Oh, that would be awesome, wouldn't it?
Yeah, just do it as an Easter egg. to
Everyone's
see if
been doing
Daniel
those
ever watches it.
caricatures, right? Everyone's been
Yeah.
doing that'll
That's
be
the hot trend.
that'll be mine.
That'll be yours and the coconut bra. Perfect.
I
Perfect,
can't think of
perfect.
a higher note to end on. Chris, we're so thankful for your time. And honestly, we could talk about all the simple analogies and go in depth also much longer. But Sean has like serious responsibilities to get to. And I don't think any of us want to hold him back. So thank you to our listeners and our audience. Follow us on LinkedIn, YouTube, Spotify, wherever you listen to your podcasts. Follow along with Shea Engineering. Chris always has something going on. Hopefully we will see you all or you'll be listening to the next one. Thank you.
Thanks, guys. We will see you at Anaheim
Yeah.
in a month.